Hi, I'm going to talk to you about my experience regarding long-term projects. And before I start, let me introduce quickly myself. My name is Pawel Lewtak. Right now, I'm working as a developer at GOG.com. If you know GOG and want to learn more what kind of cool stuff we are using there to make it happen, talk to me afterwards or tomorrow. Okay, before I start, I need to say what this talk is going to be about and what this talk is not going to be about. So, like I said, I'm going to share experience regarding long-term projects. So, everything I will say can be used and should be used for projects that last for a year, 2 years. Whenever you're building a project for more than a few years, I think you will come to the point where you will realize that, yes, I need to use it. But if you work on some short-term projects like a promo website, a conference website, and so on, some of these concepts could be used. Some of them are too big overhead with no real value added. So it's not always applicable, but hopefully you will find it useful. So first step of every project is analysis. Before you start building things, you need to figure out what it is, what needs to be built. And actually, that question, what to build, that's really big mistake you can make at the very beginning of a project. Because instead of asking what to build in terms of application like CRM, CMS, whatever, you need to ask the question, what problem do I need to solve? That's the right thing to do. Because when you focus on solving the problem, then you don't think about using framework, using some database, but you need to talk to your customer, you need to talk to a person who came up with some problem, and try to get as much information as possible to actually see what is the issue here, what are you working with. And as Mariusz Gill said, that it's root of all evil in programming, that you don't understand the problem and start writing the code right away. So basically, it's a very common I saw it many times where somebody heard an idea that, oh, I need an application that would do this. And developer thinks, okay, I'm going to use Laravel for that, React for front-end, and some NoSQL database, and so on. No, it's wrong. Stop, please. Don't do this. Instead, try to talk and figure out what is the real problem. You need to talk to business people using business language, because it's also something from experience that I saw many times developers talking to business people using words like database, table, row. For example, I'm going to store this data in a row in this table in this cool super NoSQL database. That's wrong. Use terms that business uses. Don't use IT words if you don't really have to. That way, you're talking with business people using same language. There's no place for some errors in translations. You don't need to translate business terms, business domain into programming, into code. If you can use the same words in your code, and then it's much easier for the next person that comes to your project to understand everything. And that's when domain-driven design, or DDD, can be used. Basically, that's using common language with business, and the idea is to figure out what's in the core of the business, how it works, what's the problem, how the workflow looks like. And it's very strongly connected to event storming. Event storming is a way to get all the knowledge from the business owner, for example, and draw it using post-it notes and figure out what's the flow. So, for example, we have some event that happened, it generated some data, it needs to be stored. This happening generated some other event. Using that after whole day of workshop with event storming, you get the idea how the flow of applications should look like. You get the idea what's the problem, what should be happening, and you know what you need to code. And that thing that you get from event storming will be later put into business core of your code. We'll get to that later. I want to mention shortly waterfall versus agile approach. Agile is getting bigger and bigger every year, but I wouldn't treat it as a silver bullet. If you have a problem delivering project on time, agile isn't necessarily something that would help. But where agile shines is that it allows you to deliver something really fast. It allows you to have quick feedback loop. So you make something really simple, you deliver it, you show how it looks, and then the customer says, oh, it's not what we wanted, do it from scratch. If you're using waterfall approach, then it's not possible. I mean, you get the same feedback, but it's not after 2 weeks, but after 6 months, for example. So that's a huge waste of time. And as Heraclius said, in the old times, the only thing that is constant is change. So whether you're using waterfall or agile, you can be sure that change is coming either way. So we have analysis done. We have it figured out what needs to be done. Next obvious step is architecture. So you might be thinking, okay, I'm gonna use CQRS, I'm gonna use some other architecture, but it's or microservices. Every conference needs a talk about microservices, and it's so popular. But to be honest, it's not a good way to start with microservices, as Martin Fowler said. Why? The main reason behind that is that there's so much overhead related to writing microservices. And if you don't have any experience, it can be much harder for you. Also, if your business is still small, it might not make sense to use microservices. Yeah, Netflix is using them heavily, and it makes sense in their case, but probably your company is not Netflix or Amazon or Google. So it's not your time yet. As Martin Fowler said, I would suggest to write good monolith first, and if it's really good, then think about splitting it into microservices. There's this thing called service-oriented architecture, or as Uncle Bob says, clean architecture. It looks like this. In the center, you have business code, business workflow, and so on. So that's where all the workflows you got on event storming and DD stage. That's where it should be put. So you have business code in the center. Around that, you have some use cases, controllers, frameworks, database, whatever. To the truth, it doesn't really matter what framework you are using, what database are you using. If you have the business code separated from all the other things, it's really easy to switch framework, to switch database, to switch UI, whatever you have. And regarding service-oriented architecture and clean architecture, it's important that you can communicate only deeper into the code. So controllers, database can communicate with use cases and entities, the business code, but you can't communicate from inside to outside. because that way it's no longer separated and you can no longer exchange it as easily. And the next thing I wanted to say is maybe a bit sad, but you're not unique. Some may be thinking, okay, I am unique. I am 1 in a million, but if that's the case, then there are around 7,000 people like you in the world right now. But what I mean by this is there's this stage in every developer's career when he or she decides to write her own ORM, CMS, and framework. And that's fun. That's fun. We've been there. But please don't use it for work. If you wrote your own framework, please use it for your pet projects, for your side projects, but not for work. I've been there. We had one guy who wrote his own framework and then decided to use it for our own service on production, and then left the company and nobody knew how to use it. So basically try to reuse open source software, don't reinvent the wheel, don't write things like HTTP request parser, XML parser, and so on. These things have been written many times by people smarter than you or me, so we could use that. And one other thing regarding architecture is hype. We get a lot of cool sounding words like microservices, serverless, NoSQL, blockchain, and so on. It's really tempting to get into it right away. And the previous talk about blockchain, while really interesting, and for me it was really interesting, I don't think that's really applicable in every use case. So instead of digging into it and trying to figure out how you can use it for your application, pause for a second and think whether it solves any of your problems. If switching from relational SQL databases to NoSQL databases adds any value for you, okay, do it. But if it doesn't, maybe you shouldn't. AI, deep learning, and all that stuff is really cool, but it doesn't mean it's useful in all the cases we have. Okay, so we have analysis, we have done, we considered possible choices for architecture. Next thing is tests. And when I talked about tests, I mean mostly test-driven design or development, but it's not the same thing. When you use test-driven design, yeah, you get tests, but tests are side effect. The main reason for using TDD is having well-designed code. The fact that you have tests is nice, but it's still a side effect. And besides using unit testing, you should write integration tests. You can use behavior-driven development, although it's also a bit of hype sometimes. In theory, it was presented as a tool where business people could write, validate, or read tests, but in practice, it's a myth. It doesn't happen. Business people don't really care about tests that much, which is sad. And next thing about TDD is that it's also a myth that a lot of people say, oh, I'm not using TDD because it's so big overhead for me. It requires a lot of time. I don't have time. We need to code this feature quickly and deploy to production. It's not true. As Kent Beck said, if you have problem writing tests, it's not problem with testing, but with your design, with your code. I really recommend you reading the book by Kent Beck. It's TDD by example. If you follow it closely, you will learn that using TDD approach is actually really easy. Okay, so we have written some code, we have some tests. Next obvious step is code review. I'm not going to get into what code review is, how to do it properly, and so on. Does anybody not know what code review is? Okay, I think everybody does. So what I want to underline here on code review stage is that it's perfect time for you to learn from other people. If you don't know how something is implemented, that's the time where you should ask. If you don't know why something was done in one way and not using some other approach, that's the time to ask. If you spot some bugs in the code, yeah, that's the time to mention it, to discuss the code. That's code review is often not regarded as a time to share the knowledge, but if you don't have documentation, code review is perfect opportunity to share knowledge within the team. One person wrote something, but when you read the code, you can learn what was made, what kind of changes, how it works. Okay, so we have code, tests, code review. Next thing is continuous integration. Continuous integration is basically process of building your application and making sure it works. So you pass the code to perfectly on code review step and after commit or merge to continuous integration system like Jenkins, Travis, Circus AI, and many others. And it takes care of two things. First of all, it builds your application, so it fetches all the dependencies, makes sure it works. And second of all, it runs tests. By running all the unit tests, integration tests, you can have confidence that it works. So nothing is broken after this some particular pull request. And once you have continuous integration, it's quite obvious that you need also continuous deployment. Idea behind continuous deployment is that once build on continuous integration phase passes, there are no issues there, tests are passing, build is fine, then the code gets automatically deployed to production. That way, you can save a lot of time. Because first of all, you don't keep your code in a repository for weeks or months. It gets deployed right away. Second of all, if one of the commits breaks something, you get the feedback right away. Let's say if you make a deploy after 6 months of coding and something doesn't work, you have to go through hundreds of commits and see which commit broke it. If you do deployment after each commit, it's really easy to figure out what's broken and roll back to previous version. And important thing on continuous deployment phase is that deployments doesn't equal release. So you can deploy code to production, you can deploy some new feature to production, but it doesn't mean is released. So it might be hidden or not enabled. You can use feature toggles for that. Feature toggles are basically some switch in database or distributed configuration system that allows you to quickly switch some features between on and off, enabled and disabled states. And continuous integration and deployment can make you feel like a boss because you're so confident that, yeah, my app is working. So you have your app working on production. What's next? Monitoring. Whenever you have long-term project, you need to make sure that your application is working, your servers are working, connectivity between the services is fine. So that's mostly about IT-related stuff, like CPU load, memory usage, requests coming per second, traffic, and so on. And you should have probably some kind of threshold set
that whenever this threshold is passed, you get an alert, and somebody needs to react to that alert and do something. In perfect situation, for example, you get too big CPU load, and your machines are scaled automatically. So new machines pop up, and the traffic goes to the new machines as well. Next thing closely related to monitoring are metrics. And by metrics, I mean mostly business metrics. So for example, things like customer registrations, new purchases, value of orders, people coming from partner websites and so on. These metrics are useful for business to analyze what's happening with the application, but it's also useful for developers. Let's say you release some new feature on production, and using business metrics, you can see that, hey, after releasing that optimization, we get 10% more orders. So that's some kind of motivation for developers as well. Next thing, you have monitoring, you have metrics, and thing that I think should start from the beginning as well is automation. So let's say you have that script on somebody's computer that does something on production database, or you have some other script that you needed only once in the past, but it turns out that you need it again. And you're the only person with that code. Or you need to do something once in a while, but it's not really that important. In each of those cases, you should use automation. Add this code to repository, make sure same code is run each time, make sure everybody has access to this code. That's the basic rule. If it moves, automate it. You shouldn't run any code that is not in a repository. You shouldn't have to run anything manually. For example, if you don't have continuous deployments and you do deploys, it should be just a matter of one click. You click a button and it deploys. You don't need to care what kind of actions are behind that button, what servers it needs to contact, what actions needs to be done. You just click a button and it's done. So that's really helpful if you have to work on some project really long. And for automating things in console, you can use things like thing or make file. Okay, we're getting closer to the end. Last thing, last technical thing is documentation. I know that most people don't like writing documentation, but it's really important if you have big projects. If you have big teams, a lot of code, it's easy to get lost, to forget how something works, especially if you have a lot of services connected to each other. And if you have new people coming in, you can just point them to documentation and say, read this, and if you have any questions, come to me. And also that way, even if you have really good code, really good design of the code, it can take some time to read how it works. So using documentation here is like using a shortcut to introduce somebody new to the project. And if you work on some legacy project and don't have documentation, start with README. You can add one single file, readme.txt, readme.md, whatever, and just try to explain how to run this project on your local development environment. Simple as that. Explain in few steps what needs to be done, what kind of dependencies are required, and that's a start, right? You made the first step. After that, adding more information to documentation gets easier. And you can also require some kind of documentation being written on code review stage. And the last thing important in long-term projects is communication. There's this idea that communication is a soft skill. That I'm a really good programmer, but talking to people is not my thing. So communication is not a soft skill. It's a core skill. Because after, well, you can be the best developer on your team. You can be this rock star, ninja person. But without communicating with other people, you won't be able to do everything, really. There's this quote by Denton Gentry that I really like. He said, "I wish the understanding were more widespread that we plateau in coding mid-career. It's all about communication after that." So yeah, you can learn new frameworks, you can learn new languages, you can know really a lot from technical point of view, but if you don't communicate with your teammates, with other people, well, you're not gonna do much, really. That's, if you take one thing from this talk, let it be that communication is really important in our jobs. Thank you.